Okay, here we go. We are off. Today is a great day. We're going to start. We're kind of combining sections 2.2 and 2.3. So we need to get to 3.6 before we have a test. You'll not have a test before Thanksgiving. It's just 2 days next week. But you might be able to get to a test by the week that you get back. Long division and rational roots. Question. Yeah. I'm sorry, 3 days next week. 2 days off. So, yeah, party for yourself. Unit 3.2 and 3.3 we covered today, and we'll also cover a little bit tomorrow. We start with long division. We want to divide the following polynomials. So if you take x plus 2 and divide that into 3x plus 6, we're going to ask a question in order to answer this, and we ask a question with a purpose. What do we multiply x by to get 3x? Now, the 3 is like the 6. It's not like the 3x, so it goes above the 6, okay, according to like terms. When we multiply that 3 back through, we get 3x plus 2. Or what? 3x plus 6, excuse me. Now, are you surprised that we have a 3x and a 3x right here? We made that happen, right? So when I said you start by asking, what do you multiply x by to get 3x? That's why you do that, so that these are the same and that the first set will go away. Now, in this case, they both go away, don't they? So you see, you just get 3. Now, we've always done problems like that before. Notice that this is just 3x plus 6 divided by x plus 2. If you were to factor 3 out of the top, you could see that the x plus 2's would just cancel, right? But the fact is that sometimes it's very difficult to see if things factor off and whether or not they cancel. Like example B, we have x to the third minus 6x plus 4 divided by x minus 2. Now in this situation, I take the x minus 2, I'm going to use my long division and divide it in. I have x cubed, then what? 0x squared. Anybody have a job here? Nobody has a job. Anybody work? Cole, where do you work, buddy? Okay, so Cole's working at the arena, and at the end of the month, he gets a paycheck for $104. Okay, good for you. Okay, and the boss looks at the check for $104 and says, zeros. Zeros don't have any value. We'll just cut the check for 14 and save on some ink. Okay, would you be angry about that? Yeah, you would, because that zero matters. It is a placeholder, right? Makes a big difference to you, right? At the same time, you wouldn't mind if they threw an extra zero in there, right? I mean, the power of a zero is amazing, isn't it? I mean, it's just amazing, okay? Yeah. So, for example, let's say Natalie got a 0.94 on a test, or 94%. Well, if we change that to now all of a sudden that's a little scarier, right? So, yeah. So zeros have, they are placeholders in situations, so they do matter. So what do you multiply x by to get x to the third? Put the x squared here, so we have x to the third minus 2x squared, and I will subtract. X to the third minus x to the third. We knew that was going to happen. We tried to create that situation. Now, 0x squared minus negative 2x squared, positive 2x squared, and then I drop the negative 6x. Now, you might ask yourself, why do you drop the negative 6x and not the 4 as well? We're trying to create how many terms? 2. Trying to create a binomial. That's all right. Thank you for answering. And so we have a binomial here. So that's when we can stop. So now what do you multiply x by to get 2x squared? 2x. Distribute through, and we have 2x squared minus 4x. Negative 6x minus a negative 4x. And I drop down the 4. Okay. And what do you multiply by? And we get negative 2x plus 4. And the remainder of 0. You know how to do long division, correct? It's no big deal, is it? So we're going to extend through this, but first I need to show you something that's absolutely amazing. Okay, all right? So this is one of those points where this is to help you go deeper into a test and learn to check your answers. But it's something called the remainder theorem. The remainder theorem says this. If you take a polynomial and divide it by a binomial like this, you can tell ahead of time what the remainder is going to be. What's the solution to x minus 2? What would make x minus 2 0? 2, yeah. So if we just take that 2 and we plug it in here, 2 to the third is 8 minus 12 plus 4 is 0. So what do you notice about a remainder? 0. The remainder theorem is awesome. As you look at letter D, we're going to skip letter C, we're going to go letter D. What would you plug in to make 0 for the divisor? So if you plug in 1, you get 1 minus 4 plus 2. What's 1 minus 4 plus 2? Negative 1, right? Okay. We got a negative 1. So that means that when I divide this, I should come up with negative 1 as a remainder. We can tell ahead of time. Let's see if it works out. X minus 1 goes into x to the fourth, then what? 0x cubed minus 4x squared. Zero does not have value, whether it's positive or negative, so it does not matter. And get started. What do I got? X cubed. So x cubed minus, or x to the fourth minus x cubed. Obviously, the x to the fourths go away. That's what we were trying to accomplish. And 0x cubed minus a negative x cubed, positive x cubed minus 4x squared. What do you multiply x by to get x cubed? X squared. Distribute. What do you multiply x by to get negative 3x squared? Negative 3x squared plus 3x. What do we get there? Negative 3x. I'm out of room, so I'm going to carry up here. Negative 3x plus 2. What do you multiply x by to get negative 3x? Negative 3. And I subtract those. Are we surprised we got the negative 1? No, we're not. But pretty cool that we were able to identify ahead of time. And what a great way to check your answer, right? I mean, again, you want to be at the top of the math period, you always have a way to check your answers in every situation. That way you can ensure that you're going to get every problem correct. You all get there. Yes. The remainder. So, once upon a time, you took the number 7/3, and your teacher told you, write the number 7/3 as a mixed number. And you said, okay, I'll do that. I'll write it as 2 and 1/3. Or another way of thinking of 2 and, or 2 plus 1/3, correct? Now, here's what's interesting, okay? 2 is the quotient. It's what you came up with, right? That's the quotient. And we came up with our quotient right here. But then we have a remainder. Notice what happens with the remainder. It sits there, and the divisor sits here, correct? So when we write this, we are going to take this as our quotient, and we go plus our remainder divided by, what's our divisor? X minus 1. So you could have a minus 1 over x minus 1, okay? No. You will write your answer like this. And that's very useful to us, especially when we get to calculus. We'd much rather deal with that as opposed to the original. I don't know about you guys, but long division I get tired of it because I'm very likely to make a mistake and it takes forever. So how about this? Let's not do it. All right? So let's do synthetic division instead. And synthetic division says if we take a polynomial and we divide it by a binomial, we can simply consider what the solution is to the binomial. And we can run that through the polynomial. And if you don't like it, you're more than welcome to do everything using long division instead. So, we take the 1 and we drop it down. Everybody good so far? Then we multiply it. 1 times 1. Then we add. Then we multiply. Then we add. And we multiply. And we add. So, if this is the remainder, then this is the constant, this is the linear term, and this would be the quadratic term. So x squared minus 3x minus 1. Now, sometimes people wonder, how do we know what degree we're going to come up with? Well, think about it for a second, folks. You're taking an x to the third, and you're dividing by an x. So we're going to come up with x squared. Does that make sense? So for the next one, what would you plug in to make 0 for the binomial? So we plug in -2. We have 4, 8, 0, 4, and -7. I always start by dropping the 4 and multiply. Whoop. So I get 4, 0, 0, 4, and -15. So before x to what power? Third plus 4 minus over what makes 0 for letter C? Drop the 4, multiply. I'm good so far, but now 1/4 times -7. Really? Is that possible? Is that even possible? Of course it's possible. It's just a number. Okay. 48 over 4. 41 over 4. 1/4 times 41/4. 41 over. Yep, 41 over. Whoop, try to rewrite that. 41 over 16. And then let's see, 3 would be 48 over 16. Add those and I get 89 over 16. So it looks like I've got 4x squared minus 7x plus 41/4. Got 89 over 16 then divided by what? Yeah, so think about that. 89 over 16. You want to try to get to a point you don't have to write this out all the time, folks. You know, if you're doing that, just think about it. If you were to multiply by the reciprocal, where would the 4x minus 1 end up? 5. So when you divide, you just dump it to the denominator. So 89 over 16 times 4x minus 1. Okay. Doesn't matter. I would rather not. I can tell that 1/4 is the solution. And if you notice, that's where it's undefined, correct? So this is a polynomial that's defined for all values except for 1/4. There's a vertical asymptote that exists there. Okay, kind of cool to see. Do letter D on your own. Go. Okay, there you go. So Rowan and Anna are actually used to third hour. They have, I think, what do we have, 13? We have 13 in the class. So, yep, it's just the way it works. Yo. Yes, thank you. Yes, she's judging. Will, best of luck. We hope it goes great. Maybe you can perform for us sometime, okay? Let's get a lesson. All right. Rational. Emphasis on the word rational. So, give me an example of a number that is rational. 1, 2, 4. Give me something more interesting. How about negative 19 over 123? Okay. All right. That's a rational number, is it not? Okay. Give me an irrational number. Pi, root of 2. I is imaginary, so that's not a rational number. Okay, so if there's rational numbers, then we've got a way to find them. And here's how it works. If you have a polynomial of this form, which basically means you have a constant, and you have x with a variable, and it simply just decreases as you go along. Okay, so it's written in descending form. You start with a constant, you end with a constant. Okay? If a sub n has factors, so this guy, we called those q, we called this p. If a sub n has factors of q, and a sub 0 has factors of p, then if p of x has any roots that are rational, they're of the form plus or minus p divided by q. And right now, you're still waiting like, okay, really, honestly, what is so wonderful about it? Watch it play out. It's super cool. Charlie, we want to solve x cubed minus 7x minus 6. Can you factor that? No. How do you factor something like that? You know, in solving a cubic, the formula for solving a cubic is not like the quadratic form. It's super long, super confusing. The quartic is even longer, and there are no formulas after that. So what do we even do? It's really not that bad. Because here's the cool thing. It actually does factor. And I'm going to show you how. What's the degree? 3. So it's going to have 3 solutions. P's are factors of the back, which are? That wasn't hard. What are factors of Q? So your choices are all of the P's divided by the Q's, plus or minus. Yes. We had a nice introduction last year. Now we're going to do it on steroids, okay? And it is awesome. All right. So, all we do is these choices, they're good guesses. What guess would you like to make for a solution? What'd you say? 6? I don't want to cube 6. Somebody give me something else. Okay. What's 2 cubed? Minus 14. Minus 6. Did that work? No. Try something else. Okay, 3. 3 cubed is 27. Minus 6. Hey, it works. So 3 is a solution. Now, if 3 is a solution, then what is the factor? What divides into it if 3 is x minus 3 divides into it? So it does factor. X minus 3 is a factor. Let's divide that in. Because 3 works. Because 8 minus 14 is negative 6, minus 6 is negative 12. 27 minus 21 is 6, minus 6 is 0. Yes. because I just want us to remember that x minus 3 is a factor. Okay? So I'll show you here in a second. If we divide, we get that, right? So it turns out this does factor. It factors to x squared plus 3x plus 2 times x minus 3. It does factor. If you were to multiply these together, you would get that. Great. I know that 3 is a solution. Does this factor? Yeah, it does. Yeah, x plus 2, x plus 1, x minus 3. So we've got solutions of 3, -1, and -2. Are those all listed in our choices? Yeah, there they are. Yep, November 22nd is the last day to drop this class for college credit. Okay. You still have to take it for high school. I mean, you can't drop the high school portions. Trust me, you guys, this is not the time you want to drop the class. This is one of the high. I think that for you guys, this is the highest scoring test of the year. Okay, you're gonna do great, even without a calculator. Trust me. All right, what's the degree? 3. P's are factors of the front or factors of the back. What are factors of the back? What are factors of the front? So what are my choices? Everybody good there? What would you like to try? Why don't people try 1? I don't like 1 is great, folks. Try 1. We get 1 plus 3 minus 4 equals 0. Sweet. Awesome. It works. Okay. All right. So if 1 works, what's a factor? So therefore, x minus 1 divides evenly into that. So let's divide it in. Whoa. 1, 1, 4, 4, 4, 4, 0. So it looks like you get x squared plus 4x plus 4 times x minus 1. Turns out it did factor. We're just not intelligent enough to see it. And when I say we, I'm including myself. I don't see how it factors, but the math does work. And we factor that to x plus 2 times x plus 2 times x minus 1. Hey, what are these solutions? And I'm going to list -2 twice because it's a double root. Oh, hey, what if the problem asked me on the test to graph it? Would I be able to graph it? Oh, all I have to do is show a double root at -2 and then cross up through 1. Look at that. Already in 1 minute and 30 seconds, we were able to take that graph and be able to put a perfect graph together by finding the solutions. Boom. Okay, yeah. The coolness factor is stepping up, isn't it? Yeah. Here we go, rational roots theorem. Degree. What are P's? Q's? So the choices are each of the P's divided by each of the Q's. So 3 divided by 1 is plus or minus 3. Plus or minus 3 halves. Plus minus 1 and plus minus a half. Good. Before we try 1, let's think about the problem for a second. You know it has 3 solutions. How many choices do you have? You have 8. So we got a 3 out of 8 chance of choosing right. Now, 3 out of 8 on a math test ain't very good. But 3 out of 8, if you're playing baseball, well, you're going to win the batting title, right? Well, let's change our odds. Just look at the problem. What kind of numbers should you not be plugging in if you want to come up with 0? Positive. Why would we not plug in positive numbers? Is there any way to get all positives to add up to 0? Already, we took our choices and we cut them from 8 down to 4. 3 out of 4. You bat 3 out of 4 in the major leagues, you're HOF, right? You're Hall of Fame, man, right? So 3 out of 4, let's go. Hey, I got a 3 out of 4 chance of getting right as long as I choose a negative. What negative would you like to choose? Sure. Why not negative 1? Negative 1. Let's do negative 1. Oh. So, negative 1 to the third is negative 1 times 2 is negative 2. If you square the negative 1, becomes positive. Positive 9. 10 times negative 1 is negative 10 plus the 3. And I get 7 and negative 7, which is going to give me 0. So does negative 1 work? Yes, it does. So if negative 1 works, what's the factor? X plus 1. It divides evenly. Let's divide that thing. 2, 9, 10, 3. Drop the 2. Multiply. Add. Multiply. Add. Multiply. Add. 2x squared plus 7x plus 3 times x plus 1. Turns out that thing does factor. If you didn't get 0, then you made a mistake. Remember, the remainder theorem says if we plug it in and we get 0, then we should get 0 when we do the synthetic division. 2x times x. So I bet 2x squared plus 7x plus 3 does factor, doesn't it? So therefore, I have solutions of negative 1, negative 3. So x equals negative 1/2, negative 3, negative 1. We said all of our solutions would be negative. Furthermore, are they all listed in your choices? They are. Pretty amazing. Yo, Rowan. What if the 2x squared thing didn't factor? No. Guys, right now you're getting cubics that go like this that have 3 solutions. Would it be possible to get a cubic that goes like this? Sure. So if it doesn't factor, there's a chance that it has non-real solutions. If a quadratic doesn't factor, then what would you use? Quadratic formula. So if the quadratic doesn't factor, use the quadratic formula. Furthermore, just to make your point, Rowan, it's totally possible that you could get this. You could get a cubic that has, say, a root of like, the square root of 3, and has, or negative square root of 3, a root of like the square root of 5, and a root of like the square root of 0.2. I don't know, negative 0.2. So you could have all irrational solutions, okay? You could have irrational solutions. All right. You guys got it. You need your assignment. I've cut down your assignment from last year so that it's smaller. You are welcome. These, you do the rational roots theorem, okay, in order to find the solutions. 11 through 27 odd, that would be about 8 problems. Then when you do 28 through 31, another 4 problems. You are going to do those, but you're going to also sketch the graph, even though the book doesn't ask you to. I'd like you to sketch a graph so we are able to connect those 2 together. That's a big reason why we're doing this, is to make sure we know what the graphs look like. Okay? The book pages are online. And you have 10 minutes here to work today. Tomorrow you will not receive a new assignment. We will simply finish up the notes, and you will then be able to continue on with the assignment that you have right now. You can pay me in cash or credit. I would accept hugs. I think that that's part of the failure of our education system, just not enough hugs. So, but all right. Who are we missing today? I think that that's our only one, right? I think we're good. All right.